Hi students, this is Mr. Ezra in our very first screencast for the Algebra 2 course. We're going to introduce some characteristics of quadratic graphs. So our goal today is going to be to just begin to learn some of the terminology that we're going to use to analyze numbers and functions. And specifically in this unit, we're going to be talking about quadratic functions, functions that have a graph that looks like either a smile, hello, or a frown. One of the two. So what can you tell me about this graph? I'm going to listen here and see if I can hear you speaking to me through time and space. Um, what can you tell me? Well, I imagine that some of you are looking at this thing and thinking, I think we studied this things before. It's something that's like called a quadratic or something. You would be right. Maybe last year you looked at some quadratics for a little bit. Another term that we use for this graph that you may have seen is a parabola. Parabola. I bet that some of you are saying, well, it kind of goes down and then it goes back up, right? So that's a characteristic of this graph is it goes down and then it goes back up. Some of you might notice that there's essentially an arrow on both ends. By the way, anytime we have a graph in this class, there's not an arrow at the end. Assume that there is one. If it goes all the way to the edge of the graph, we're going to assume that it keeps going forever. Some of you might notice there's a lowest point here. That's a possibility. Some of you might still be thinking, hey, that kind of looks like a smiley face. I add some teeth in there. No? Okay, well, maybe you're not thinking about the smiley face, but there's lots of things that this function tells us. And today we are just going to be focusing in on a few of those characteristics. Some notation that we need to be comfortable with that you've probably seen before in previous math classes. We're going to be using a lot of interval notation this year. Now, interval notation is a notation that represents an interval of numbers as a pair of numbers. So if I write parentheses 2 comma 6 parentheses, what I'm really saying is all the numbers between 2 and 6. In brackets, if I say 2 comma 6, and we'll talk more about this in a minute, what I'm saying is all the numbers in between 2 and 6, but also including 2 and 6. So parentheses are kind of like ways to say the numbers are included, but we're talking about all the things between them, and the brackets are telling us, hey, include this number, it's part of it, okay? This notation is, once you get used to it, it's simple, it's fast, it's easy to use. Set notation is a little bit more complicated. This is when we use inequalities to describe values. So if I wanted to describe this 2 to 6 thing, I would have to say 2 is less than x is less than 6 for the top one. And for the one in brackets there, the 2 comma 6 in brackets, I'd have to say 2 is less than or equal to x is less than or equal to 6. It's a little more clunky. It's not as quick and easy to write, but it's still a great way to represent an interval of numbers. You might include more information sometimes, like what type of numbers you're talking about. We talked about numbers in class the other day, the different types of numbers. Are they just integers? Are they real numbers? What all types of numbers? For all intensive purposes for our course, when we write something in interval notation, unless we state it differently, we're talking about real numbers. So in a minute, we're going to talk about the domain and range of a function. And if I write an interval, I'm going to be talking about the real numbers between 2 and 6, not just the integers. If I'm talking about the integers, I'll either list them out or I'll be more specific. So again, in interval notation, a bracket means that you include the number. It's like less than or equal to. And a parentheses means that you don't include the number, like just less than. And you can have a bracket on one end and a parentheses on the other end. We're going to be talking about infinity a bit in this class. And anytime you use infinity in interval notation, infinity always gets parentheses. And the reason is infinity is not really a number. I mean, it's a direction that we're traveling. We're going towards infinity. We're getting closer and closer to this big thing that we can never quite get to. So since it's not a thing that you can get to, since it's not a number, you can't include it as part of your solution. You can only say that I'm getting everything less than it. I'm getting closer and closer and closer to infinity. So infinity is always going to get parentheses, but sometimes we're including the number, and we'll talk about that more in a little bit. First off, domain and range. You've hopefully seen these words before. They're not new. Remember that the domain is all of the x values in a graph, all the x values in a graph. In contextual problems, we call these the independent variables, and it's what you put into the function. So in function notation, a lot of times you say f of x because we're plugging in x to the f function. The range, on the other hand, is all of the y values in the graph. Okay, in contextual word problems, these are called the dependent variables because we would say that changes in the range depend on changes in the domain. And it is the outcome of the function. Once you plug in that x value into the function, it's what you get out. So if I have the simple function f of x equals 2x plus 3, right? The x values are all the things that I can plug in for x. Like I can plug in a 2 for x. And if I plug in a 2 for x, that would be 2 times 2, or 4, plus 3, which is 7. I could plug in a negative 10. 2 times negative 10 is negative 20, plus 3 is negative 17. In fact, I can plug in any number that I want to. I can plug in 2.6, I can plug in pi, I can plug in anything that I want to, and I would always get an outcome for this function. Well, all of those possible x values are called the domain, and all of the possible y values are called the range. And we're going to specifically look at the domain and range of a quadratic function. So remember, if it goes to the edge of the graph, it's assumed to be an arrow. So we want to know, what is the domain and range of this function? Okay. Well, remember we said that the domain is left to right. We have an arrow on the left, which means that essentially this function keeps going forever for the left. We're always going to have -1, -2, -3, -4, -5. All of these x values to the left forever are going to be included as part of this function. So our domain is not starting at a number, it's starting at negative infinity. And what I mean is an x value of negative infinity. We went forever to the left, we would be able to go up forever and get to this function somewhere. All right. Same thing as to the right. As we get to the right forever, we're going towards positive infinity. So the domain of the function is negative infinity to positive infinity. Now, what did I say about interval notation? We're going to use parentheses for domain. Now, remember you to use the less than symbols. Order is important. Intervals, as well as the set notation, need to be from least to greatest. So you never want to get these swapped around. I have students all the time that want to say from infinity to negative infinity because they're just looking at the graph weird, but it has to be from left to right. It has to be from negative to positive infinity. All right, well, what about the range? The range, on the other hand, is bottom to top. So whereas domain is left to right on the graph, what's possible for x? The range is bottom to top. What's possible for the y value? So I want to find the bottom of this function, and I see that the bottom of this function is at a y value of, put it over here to the side, -2. That's the lowest point on the function, and I want to point out that that point is on the function. When I try to find the highest point, I can't find it because I have this arrow going up. This arrow that goes up forever towards positive infinity. And by the way, it goes up forever on the other side towards positive. So every single y value from this -2 is going to be on this function. A y value of -1 is on there twice. A y value of 1 is on there twice. A y value of 5 is on there twice. A y value of 2 million is on there twice. It's just way up the function. So if we're going bottom to top, the lowest point on the function for the range is -2. And the highest point is not calculable. We can't calculate it. It's infinity. Now remember we said that if the number is included, and -2 is included, it's on the function, then it gets a bracket. You can do this every time. You're always going to get domain and range right. And you'll notice something with these types of functions, that the domain is consistently going to be -infinity to +infinity. And the range is consistently going to be from the vertex to +infinity. Or if we have a function that's open down, our range would be from the vertex up. Or if it's open down, then it's going to be from -infinity, because it's always bottom to top up to that vertex, whatever the vertex is. Okay, so either vertex to +infinity or +infinity to the vertex, and make sure that you're using a bracket on the vertex because it is included. So hopefully you're not panicking yet. Things aren't too crazy yet. We do have one more thing to talk about, and that is the interval of increase or decrease. When we talk about the interval of increase or the interval of decrease, well, really there are three different types of intervals that we look at. There's increasing, decreasing, and constant. I want you to notice that we're always sweeping from left to right. In other words, if I have this function, this crazy function, and I want to know about intervals of increase and decrease, I'm going to start at the far left and start going left to right. And along this function, it's increasing, which means that it's going up from left to right, and then decreasing downhill, and then increasing uphill, and then decreasing downhill, and then increasing uphill. So lots of things can go on in a function. Well, we're going to be talking about quadratic, so it's going to be much less curvy. There's not going to be as much increasing and decreasing. Now, with these types of functions, we won't see a constant interval. But a constant interval would be, let's say we were increasing, we stopped increasing, we had a flat line, we started increasing again, and then maybe we started to decrease. So this would be increasing here along this guy, because it's going uphill. And then it's flat here, horizontal line, that would be constant, increasing again, and then decreasing. So always left to right, and you can get it every time. So our question asks us to give the intervals of increase and decrease. We are going to write these in interval notation always, but when we do this, we are always, I should capitalize this and put it in flashing lights, and you just need to know this. It is always going to use the x values. And this is going to be hard for some of you, I know, because I've taught this course long enough. But when we start on the left side, we are only interested in where it is increasing or decreasing along the x-axis. I don't care about these numbers here for these intervals, only the numbers from left to right. So the first thing that I might want to do is I might want to break this guy up. I might want to say, well, I'm starting on the left, and I notice that on the left, remember that's an arrow there, it's decreasing, and it stops decreasing right here. This is called the vertex, by the way. It stops decreasing at the vertex. And that vertex has an x value of 1. This is the x value where it changes direction and it starts to increase from left to right. Now, because of the arrow, let's change that color. Because of the arrow, that means that we're going to be decreasing forever from -infinity, because remember, we're coming along the x-axis here. Even though this is way up here, I don't care how tall or how far up the function it is, I know that it's decreasing from -infinity to +1. And then at +1, it starts to increase to +infinity. So I have an interval of decrease. That interval of decrease is from -infinity to 1. And I have an interval of increase from 1 to infinity. Now, you will always use parentheses for these intervals because when we talk about an interval, I can't say that 1 is included because it has to be an interval from one thing to another thing, right? So 1 is just the start of the interval, and infinity is the end of the interval, and the interval is everything in between it. So always use x values, always use, whoops, parentheses. Well, let's make that plural. All right. Hopefully some of these vocabulary terms are coming back to you. We will continue to talk about characteristics in the next video. Lots more characteristics. I look forward to seeing you in class.